to introduce Professor Dinesh Kumar Vishwakarma sir, a distinguished academician, researcher and academic leader, currently serving as professor and head of Department of Information Technology at Delhi Technical University, DTU Delhi. Professor Vishwakarma has over 18 years of experience in teaching, research, and academic administration. He earned his PhD in computer science uh, in computer vision and machine learning from DTU in 2016 and completed his MTech from MNIT Allahabad. At DTU, he had held key leadership positions including head of department, associate dean, and chief warden, demonstrating his commitment to both academic and student development. His research expertise span computer vision, deep learning, human action recognition, video understanding, multimedia analysis, social media analysis, fake news detection, and trustworthy AI. He has been continuously ranked among top 2% of scientists worldwide by Stanford University from 2021 to 2025. Highlighting his global research impact, he has published various papers in SCI and ESCI Scopus and serve as associate editor for IEEE TCS-VT, contributing to shape international standard in AI and multimedia system. Professor Vishwakarma is a senior member of IEEE and lifetime member of ISTE and has served multiple research excellence awards from DTU. His work exemplifies the research innovation, academic leadership, and social impact. We are truly honored to have him with us today. Please join me in welcoming Professor Dinesh Kumar Vishwakarma, sir. Over to you, sir.
Thank you, Dr. Yeah, thank you, Dr. Seth, for introducing me. It's really a pleasure for me to interact you and also joining this particular program which your university is organizing. Really, it's my great honor and pleasure. Thank you very much for inviting me, and also the organizers, those who are organizing this particular program. It's a really very wonderful program. What exactly I saw that the topics, etc., which you have selected, really, it's a very nice and great importance in current scenario. So I'm very thankful. So let us share
Sir?
my screen. I
Yes.
hope I'm audible.
Yes, sir, you are audible.
Yeah. Okay.
Hello, sir. Dinesh, sir.
Hello, yes, Swet, can you hear me?
Yes, I can hear you now, sir. But screen is
Yeah,
not
actually,
visible.
I
That's the
don't
reason I
have
asked.
an app of this one. So do I install because actually I'm trying to join means share with the browser. So
Yeah.
uh, mm, I'm not able to basically share my screen.
Just so do I help you out on the same?
No, just wait. I'm trying actually. Otherwise,
Okay.
I have to change my.
Sure, sir. Sure. Sure.
Yeah, let me. Yes, can you hear me?
Yeah, sir. Yeah, sir. We can hear you.
Okay. I hope my screen is visible.
Yes, sir. Yes, sir. Yes, sir. Screen is visible now.
Yeah, okay. Yeah, now is this PPT? Can you see?
Yes. Yes, sir. Yes, sir. That is
Yeah, okay,
readable.
okay, thank you. Thank you very much.
Thank you,
So
sir.
again, let I thank you for introducing me. So, and also my pleasure to join this program. So, let I'm coming to my talk topic. So, hate speech detection across text, images, and videos. Specifically, we are going to talk hate speech detection in multimodal means data. So here exactly we can see now in these days it's basically the era of social media, and also over the social media we are witnessing a lot of the content that is going to be shared among our different users as well as the social networks that we are sharing, not the multimedia content we are sharing. So that multimedia content is itself, sometime it is for the good, sometime it is for the bad. So like hate speech is now, it is one of the very important aspects of the society that is now becoming in these days that we are talking about it, but it occurs at the very initial days too. Once even we go with this history, so in India itself, there are many times at even at the time of what I can say around 1980s in India itself, that was a hate speech that has been even observed, and that hate speech specifically I can tell about the like in case of Jammu and Kashmir and those regions exactly what was happened. that time a certain religions people they started making a I mean some kind of even speeches they are trying to spread in terms of hate speech, and there are few specific people those who are starting for this, and because there are other people those who are followers of those, and they started creating a nuisance for others whom against the hate speech that was given. And what the fact I'm quoting regarding this is not my own facts. It is well available in literature. It is available over there, and also even I will try to demonstrate some of the aspects of hate speech that has been noticed by even United Nations, and they have also separately created some sections of the United Nation that notices and that also certain regulations. They have also given some kind of mandate for the every country how to stop this hate speech, because it is becoming more impactful at the time of
அவன் பேர் என்னடா?
yeah, is this yeah, are you able to hear me?
Yeah. Someone is like someone has
Yeah.
unmuted. Uh,
Okay.
that's
Okay. Okay.
sorry,
Okay.
sir.
So that hate speech now in these days coming in the specifically in the form of text, sometime in images, and sometime in video. So that we will try to cover in this talk, that what is the significance and also how we will be able to somewhere detect it. So now here we can see it is an overview of social media threats. So these all the aspects and different means aspects of hate speech that here we are trying to notice, and also the social media threats that in these days that are becoming very means dangerous for the society, and they are also means sometimes fool the society. So here we first aspects we can see misinformation and disinformation. Now, this due to rise of this social networks and availability of these different media platforms, that we are easily we are going to exchange our information, we can share and we can spread it. And many times we are not noticing whatever the content that we are receiving, that we are exactly forwarding into certain groups, and also we are sharing with our friends. And so that may be the information which we are trying to share, that may be a misinformation, means the fact which that is going to quote in that one, that is not the true. And it is also sometimes it is presented in the form which even we don't think, and we do not even use our minds sometimes once we say it. So these things are happening, and also there's even more now nuisance that is we are observing, like cyberbullying, online harassment, where we are finding a digital arrest, abuse in humiliation, means threats. So, and another is like a deep fake. So that is also one of the aspects where we people are trying to even create a audio as well as the video of a person, and that they are creating in sense of a negative, means that anything which you haven't even told, or you are not going to tell anything against of anyone, but now there is in the video that you may be telling something to against of anyone, or even sometimes you may be abusing, or even you are making a false kind of commitment in respect of a person who is exactly a very popular personality, and that you are trying to that person looks, but that actually person is not there. So hate speech is also that is a very popular now in these days becoming, because that has some business role too, even in aspects of business role, what I can say, because hate speeches many times some of the political leaders they are having they want that become a popular, they want to even in respect to the favor of anyone's, means they are trying to create their own impact, they are not thinking, they are having their own hidden agenda, and those agenda they are going to promote with the hate speeches too. So I personally believe that the political leaders, those who are, they are also doing their own business, and with that business, they are trying to influence the people. Either it is a positive way. Positive way, if they are going to influence, it requires more energy, but people don't want to give even more energy because they want to create something which is a means that they that has to be breaking, as well as the nuisance that is creating, or we can say like sensation that everyone wants to create, so that they can easily they can attract the people. So in now in these days that are even resources are available, and also we are having tools and technologies through which we can do, but these are somewhere impacting the society, so that we have to even look how we can protect it. So now there is security and even a financial risk. So here we can see like a scam and social engineering, fake profiling, phishing links, even romance scam, everything now it is happening. And also those are impacting like a social and psychological risk. So another is social and psychological risk, that is a more important, especially like a reputational damage and cancel culture. So reputational damage, that it is a more noticed at the time of election. The person now there's a lot of the AI based content they are generating for an individual, that even individual is not involved in such kind of things, but now in the video or in the images they are trying to create a false information that they are
Yeah.
trying to induce. So that is
ये
the
उसी का जो मैं कह रहा था. Kindly unmute your mics only. That because that is interrupting. So someone who have opened their mic, they have to just mute it up. Sorry, sir.
Sir,
Sorry for.
just give me 1 minute. I'm just muting everyone. Professor Dinesh, sir, please unmute yourself after 5 seconds. I'm just unmuting to all.
okay.
You can unmute now.
Yeah. Yes, can I now start?
Yes, sir. Yes, sir. You can start now.
Yeah, thank you. Thank you. So now here also we can note and see on the right side where non-consensual content sharing, people are doing this also, where revenge porn, leakage photos, videos. So these all are the basically now in these days we are witnessing. The few I'm discussing, but still a lot of the means now fake content that is available over the social media, and one of the aspects which we today will try to have a hate speech. But let me see what is the new face of now media. The new face of online hate is, here we can see, that is over the digital networks, means these are the basically involved like a evolution from simple text based abuse, complex multimedia hate, and memes based hate, coded language, implicit hate, text image mismatch, and a explosion of a short video platform, so reels, etc. So these all are coming in the new phase of around online hate. That, so that also provide us a lot of challenge to detect such things. So hate speech, first we have to understand what is hate and what is non-hate. So here we can see hate speech, the definition which we are taking for the hate speech itself, it is also means given by United Nations strategic and plan of action on hate speech. So here the content which we are now going to highlight, that is the create more importance, like how we understand its impact, and then because that impact itself is noticed by United Nations, that is it is a hate speech in terms which we used to say, so that refers offensive discourse targeting an individual or a group, and on the basis of inherent characteristics such as we can say about the race, region, and gender. If we are finding out, if we are noticing, if we are indicating to anyone with, based upon these like race, religion, and gender, then that may be a like a hate content. So any kind of communication in a speech, writing a behavior that attacks and uses means that is a pejorative and discriminatory language with a reference to any individual or a person. So this is the definition through which we can say, like sometime we used to even say if anyone's based upon their religion, based upon even color, also we used to say, even sometime it has also noticed by based upon their nationality. So all these, if we are identifying anyone's we are noticing and we are indicating anyone, so that is basically the hate. So here also we can see that how this is means that form of a communication sometimes we used to have, which also a person and group that is based upon these we are doing, so it comes under the hate speech. So we will try to see this one here also, the definition, this particular definitions which we have taken, like hate speech is a complex phenomena intrinsically associated with the relationship between the group or relies on the language nuisance. So even here also in this particular table we can see that how these even content, those contents that are in terms of hate speech. So these definitions like EU code of conduct, they have also specified what is the hate. So here they have given if there is a target, if there is a religion, if there is gender discrimination, race and ethnicity, or even a radicalization violence. If this is there, then they are saying it is a hate. And similarly, there is an International Minority Association, ILGA. They have also described if we are going to target anyone like target and there is no religion like this here violence, if this has, then they are showing. So even there are also some scientific paper that also tells like how to so all these definitions like this here you can see Facebook how they used to detect that. Facebook itself, they have their own mechanism to block and to not promote sometime, but still it depends upon the situation and also how much the person even what I can say sometime influential, or also we can say because in developing countries it has been noticed that Facebook, the definition which they have given, whether they are following or not, because that is up to there. But in they are in developing countries, they have favored to the ruling parties, not blocking the content of rulers, and but they are blocking the content of oppositions. So that has been noticed. Similarly, we can see the Twitter, they have also their own definition, and these definitions are based upon these individual traits like target, religion, gender. So YouTube itself, so because Facebook, Twitter, and YouTube that we use mostly. So here they have identified their own mechanism that how they use to identify the hate content. So that they have. Here also we can see there are many people, they have some right, and they used to even try to say that it's my freedom of speech. So freedom of speech is good for any democracy, any democratic system, it is good. But exactly, we have to be in the limit which do not harm to any individual. If we are not going to that, then here we can see like a freedom of speech, the right to express the opinion and ideas without government restriction. So, like a hate speech that attacks or demean or a group of based on attributes like race, gender, if we are. So, purpose is also here freedom of speech, like it is a that is a provided to enable open dialogues, debates, and democratic participation. So here there are some traits through which we can understand what is a freedom of speech and what is a hate speech. So we exactly categorize these, and based upon these six aspects that we have noticed, and even some of the like here examples also criticizing government policies, protesting peacefully, like and satire. So even also be used to see satire of where like so sorry that comes into a astak. We have seen that. So that is the means it comes under the freedom of speech. So that's why they used to have satires of the even opposition parties as well as the ruling party too. Both they are going to have because that comes under the
freedom of speech. So, but hate speech like promoting racial supremacy, using slur to demean a community, inciting mob violence. So such things means we have to understand what is the freedom of speech and what is hate speech. So these six aspects that clearly defines that how these has to be ended. So here also we can see there is one more aspect in hate speech now are becoming also popular like cyberbullying, racism, sexism, gender discrimination, radicalization, abusive language, offensive language, and religious. So over the social networks, social media, it is available. So where we can see that how few of the examples where we can exactly connect and we can understand what is hate speech. Now here we can see first part here there are the first three examples which we are considering, that is a hate speech, and then also we have seen that cyberbullying or abusing. Like in the first case, John Doe is a religion name from a nationality. Dirty is a bisexual and violent. If we are writing this, this is a hate speech as well as cyberbullying, abusive, so all that exists in this. But now second example, John Doe is dirty. So if we are writing in this way, so here we can see it's also hate speech, but here you can see in this one, it's not a gender. This or we can say so even kind of sexism or such thing like racism or radicalization. So these are the very set standard definitions that we have even taken, and these are from well established literature that we have taken. So where we can exactly see and understand that how we decide that which one is a, because once we are going to built up algorithm which detects this thing. So we have to also now well aware about the domain. If we are well aware about the domain, then accordingly we can frame, we can even model our own frameworks which can detect such things. So here also you can see some of the examples that how it's a hate speech. Like example in this case, you can see like अखिलेश यादव और सीएम योगी अंतांश कहा जो लोग वैक्सीन पर दुष्प्रचार कर रहे थे आप लोगों ने वैक्सीन लगवा के उन लोगों के मुंह पर तमाचा मार दिया. So here now you can see here in this one like it's a target is individual. So individual has been targeted. Similarly here there is organizations you can see राष्ट्रपति शासन लगाने वाला स्टंट बीजेपी वाले बंगाल में भी कर चुके थे, अपनी ही गाड़ियों पर पत्थर चलवा दिए थे, याद है कि क्या नहीं देशवासी. So here you can see that how these are means we can understand in this one what is the target is a organization. So there is an organization which has been targeted here. So these even the example which I am quoting, this is not my own example. Here in the bottom side, you can see the reference which we have taken. In this reference, these has been clearly published. This is the Asian transaction where we have taken. Here also you can see a lot of the definition where there is a directed hate speech, directed and generalized hate speech means where like ready to make headlines. So against the LGBT community that was given. So in now it's emerging and it's even in US also US a lot of the things that has been noticed and where such kind of nonsense are. So there is a very much concern regarding the hate speech, like no to hate. That is the agenda, that is the slogan they in United Nations they have given. Here also you can see, specifically over here you can see and notice that this is a there is a clear cut means guidelines regarding the hate speech where United Nations they have taken into a cognizance of this and they built up this particular section. And also here means United Nations General Secretary they have also even quoted it's important. Hate speech is an alarm, means an alarm bell. The louder its ring, the greater of threats of genocide it preceded and promotes violence. So now this particular statement, if we analyze, then we itself consider and we can see how it is dangerous for the society. The word specifically they have taken this particular word, like many times hate speech that has created a genocide, means those who are back of the mind, they are how they are using their mind to trigger the people with their words. Hate speech, with their words they are triggering the people, and that is going to become an impact which is like a genocide that is created. So, United Nations strategy and plan of action on hate speech. This was built up in 18th June 2019 due to rising of this. So, there is a plan of action where 13 commitments to the action by UN based on four key principles. Those four key principles they have taken like a strategy and implementation must be in line with the right of freedom of opinion and expression, means the strategy which we have taken it must be aligned with this, not like to stop freedom of speech. We want to have a freedom of speech but to restrict in a certain manner where no one is going to be basically targeted or even harmed. So another is that tackling hate speech is the responsibility of all. Here you we have to understand it is a responsibility of all, not like a we think that government will do, society will do, private sector will do. It's a responsibility of all and individuals, every individuals. United Nations intend to support new generation of digital citizens, empowered to recognize, reject, and stand up the hate speech in digital age. And the fourth one is a strategy call for coordinated data collection, because this is also very, very important part. There's a call of strategy, coordinated data collection and research, including the root causes and drivers and conditions conducive that drives hate. So these four principles that based upon this 13 commitments they built up. And these are the 13 commitments that was built up, that was even decided. These commitments like monitoring and analyzing hate speech. This is one aspect. Addressing root cause and driver for actors of hate speech. Engaging and supporting the victims of hate speech, because this create a very negative impact over the individuals once it is going to happen. Convene relevant actors. So using technology on the result like these all 13 commitments, which itself that shows that how it is a dangerous kind of thing. So impact of a hate speech, here psychological impact and social impact. Both are impact, means it has both aspects. So psychological aspect, emotional distress, reduced self-esteem, psychological trauma, stress and mental issue, alienation and isolation. So social effect, polarization and division, and this is done by most of the political people. This is polarization and division, erosion of social cohesion, violence and discrimination, undermining social progress, impact of democracy and governance. So a lot of that. So now comes to our mind that why we are looking for text, images, and videos. So because the multimodal data in current days, it is a hate speeches are spreading in terms of multimodalities. So here we can see hate speech encoded in visual cues, symbols, and gestures. So that is all there. Sarcasm and context loss in text-only system. So emergence of multimodal information where deepfake, doctored images. So when even a model detects safe text with harmful memes. So we can see on the right side that how these are means I support diversity like this. Here there is a fake kind of content that has created. So which looks even images as well as the text. So that's So here multimodal data, we have to understand where text, audio, images, and videos that are there. Human means cognition means naturally integrates multiple sensories because we itself are means multimodal. So accordingly, we try to build up the multimodal. So multimodal information processing aims to replicate the ability even of machines to improve understanding, reasoning, and interaction. So that's why we basically more of the work that even reports multimodal hate speech detection. So here enabling next generation AI application, that is also very important. So self-driving, healthcare, even virtual assistants, augmented reality, visual question answering. So these basically like here we can see many of the today's state of art where we are finding like ChatGPT, Gemini, Claudia, all are multimodal supporting text, images, and code to speech. So deep learning models that are more responsible for detecting hate speech. So those models like text-based techniques are also available, which is one of the very popular is a BERT, robot, llama-based, and hate classification, toxicity scoring, and contextual embedding. So for the image-based, visual transformers, for symbolic hate detection, logos, symbols, and gesture recognitions, memes, reasoning, etc. That is this one. But multimodal fusion model, early and late hybrid fusion, vision language, joint reasoning. So LLMs, all those are basically the models that are becoming more responsible. Here we can see active social media users, they are growing, and so these all users, that is basically the I can say it may be a more motivation factors because more people are joining our social media, and social media this kind of content people are sharing and they are going to have the benefit. So here even this statics also motivates us over the Facebook, YouTube, WhatsApp. We can see that even the how the numbers monthly active users in the millions like over the Facebook, YouTube that they are increasing. And these based upon these we have that is also very important that why which social media that we have to try to detect such things, so that also gives us a concern because once where there is more users, so we have to build up our algorithm which can detect over those. So here online safety and responsibility that also has, so where the key objectives preventing online safety and responsibility, that is also now current days or even in coming future it becomes very important and integral part. So key objectives are that preventing a real word harm, regulatory and legal compliances, protecting freedom of expression, corporate social responsibility, improving online user experience, that all that we are doing. So basically that these objectives that becomes basically key objectives for online safety and responsibility, so that we are trying to even follow these things and we are trying to even improve these things. So a lot of the applications of the hate speeches that are also there, like law enforcement, or where the police, etc., law enforcement agencies, evidence collection. Now, if you are doing anything in the real world and you are making any post over there, so they are trying to relate over the social media post as well as the action which you are going to do. So that is the evidence collection that they are going, and also the criminal investigation that is becoming important. Social media moderation, where real-time filtering, comment analysis, all these hate speech. So policy enforcement, even user reporting. So this all that becomes this means a hate speech ecosystem where applications are becoming more important. Like here also we can see over the Facebook anti-bullying tool that we can build a education platform, law enforcement, online content moderation, social media monitoring. All these becomes more applicable, but not as easy. A lot of the challenges are also there. Those challenges that makes more importance, like challenges in multimodal hate speech detection. The first one here we can see what exactly happened in this one here. the benign co-founder problem, where semantic gap that we can notice. You look great. If you are going to send someone, like you are writing a text with the dog emoji, you are sending someone to this. So we can understand. This is a very, very clear cut. Like means where we are making it and to which is a kind of hate content. Similarly, in the second one, you can see contextual and cultural nuisance means context which you are doing, and also they are having a cultural. So implicit hate, dog whistle, and sarcastic. So meaning relies on deep culture and context and evolving trends. So data scarcity, quality, so resource bottleneck, where they are trying to label video data, which means human annotators, they are like they are going to have hate and non-hate. So lack of large high quality label data, this is also one of the limitation. And also technical fusion means like over reliance on the text modalities. We are more relying on the text. Audio complexity, tone, code mixing, often weakly. So adversarial attacks, that is also one of the very important aspects of machine learning nowadays. Adversarial attacks mean the model which we built up, that model, even sometimes there is adversarial attacks where the meaning whatever you have given to the model ideally made for good thing, but now it may be even mislead, or even the decision which the model is giving, that may be changed with the attacks of adversarial attack. So here also we can see some of the challenges. If you are sending someone, love the way you are fast, someone here, this is the very sloth or a slow moving in mammals or animals native in anthropological rainforest of Central America, South America, that is there. So, but here you can see in the images, you are sending this one and you are saying you are fast, but sending this kind of slip. Love the way you are fast. So here you can see this one is a positive, but now love the way the sloth moves. So that is basically means here exactly they are what they are trying to do. Sample images and text co-founder. Left image of shows hate full mean. In contrast, the middle, a right image, the left illustrates its co-founders, means via changing the text or images of non-hate full means. So these are the challenges that makes us to understand. So here there is a frameworks of hate speech, which we can see that how this particularly means the means frameworks that is going to deal the data which we have. So in this one, the left part, that we can see data preparation, where we have a data pre-processing, training and testing part, and this is the part of feature extraction. And specifically in text data, we use to have feature approaches like a TF-RDF, semantic, with pause. But here there are deep learning based approaches that are also becoming word embedding, fast text, glove, ERMO, like a word to big. But so these, and then there is a model learning like a classifiers, yeah, deep learning based classifiers. So these are also categorized into multi-class, or sometime it is into hate or not. So here you can see this is a more elaborative hate speech. So we have this general system. Now here also we can see multimodal framework operative views, where we have images, where we have videos, where we have audio. Then we are making it a multimodal framework. So now on the top here we can see in this one, we have a text, we have even a text input from the social media. Then here we have audio. So that is going to process through this pre-processing layer. Then it is going to have feature extraction here. Then we are going to have a, even this one multimodal fusion. Then we are building a model, and then output layer, and then we are classifying it. So this way we are going to have, here we have a video. So for the video, how we use to process were like frames, audio, and text, because now in these days video has also its caption. So caption is going to be here, and the audio of this is going to here, then it's a frame is going to here. So means here image feature extraction, means we can use images. Then here we can use audio based feature like MFCC, means mel frequency shifter coefficient, so that we did training. And then here we have text, so we use NLP, through which we use to convert the text into a vectors. So word embedding approaches like tokenization, limitation, removing stop words, and then we are converting into TF, IDF, or word of, means this is a bag of words that we are making. Then we are fusing and then we are classifying it where this. So multimodal frameworks. This is one of the work that we did, and this particular work which we are going to demonstrate. This is our own work which has been already means published and available, which is a multimodal hate speech detection via multi-scale visual kernel and knowledge distillation architecture. So in this one, the model itself, it is a multimodal. So where the modalities that we can see, there's image and text. So multi input image, and it's a caption which is available. So that we used to do in this one. Now everyone now needs to work on the basis being less hate specifically online. So like text is going to be extracted, then on the bottom side we are going to have this image. So this is going to be means this is going to be text. So knowledge based distillation based attention caption model that we have, and here this one is just 16 features. Then we are finding, and then we are again fusing it, which is 30. Then fully connected layer, and then we are classifying it as a hate and non-hate. Very simple framework, which is also very logical framework, because we can see over the images text and there's an image that is available. So that's why we used to have this kind. So here we have to understand what is the multi-scale kernel attentive visual module. So exactly in this one, what was the thing, like we are giving the input feature vector, which is having a 256 dimension, and then we are applying over it, and that is we used to apply over the kernel, and then further we used to process it, and now we are making it the visual branch architecture, which is basically aggregated residual transformation attention model that is going to be mixed, and then we get the multi-directional, means visual attention model that we applies. Then we get the features, and now here this one is a again a visual attention module multi-direction. So where how we basically make it and how we try to is process such a data, that is where we have a like a different like a channel pool, and then permute, and then we apply, means this is the one of the deep learning simplest architecture that we try to get the basically visual information. And then there is a text data, specifically that was the images, where we are trying to get the what is the images. And next is the text data which we have, that also we process, which is knowledge distillation based attention caption module. So here a very simple way through which like that we use to process, like we have a text, and then it is going to additional tokenize, and then token ID and general input marks, and then we use to generate the features that we have. And the data sets which we have taken to test the performance, means the framework which we propose, and we check its performance over a public data sets that is available. It was for hate speeches. So here we can see it is a multimodal meme data set for identifying offensive means content in input and text model. And the source for it is a 2016 US election, presidential election, where the sizes of these 743 memes, offensive was 305, and non-offensive was this one. And few of the sample images which we can see, there's image as well as caption text. So it basically hate speeches that is more popular once this particular person comes into picture, means specifically over the digital media. And in the started from basically 2016 US election. So here, Facebook, another data set is a Facebook hateful memes, a data set which is a source of Facebook AI 2020. Here also we can see 10,000 memes. It's a exactly balanced data set where we can notice that 5,000 hateful and non-hateful content. And right side some of the sample images also we can see. Like there is a rose flower, love the way you smell today. How it can be possible? So if this kind of images somewhere you are sharing, so definitely it's a uh, someone you are making a negative kind of comment. So looks how many even people love to you. So that is also somewhere. So this is a hateful and not hateful that you can see that how. So the third data set which we have also taken, that is a multimodal hate speech data set, 150K data set collected from like Twitter. That's also very popular social media platform, and it is having 1,50,000 tweets. So text will here also we can see this is a this one few more categories that has been taken. So like these are the some of the categories like 5 categories that we can notice that one is a non-hate and this all are comes into the hate. So the data set that is available in this here overall statics of all these data sets which we have taken, and the training set, validation set, and test set that we have, how we basically check the performance, how we do the experiments, so that we have also given the statics. So this is also the model hyperparameters which we has been use and we optimize those models, so that we have also used these model hyperparameters for our experiments. So the performance of the model that we notice in these terms, like accuracy, precision, recall, F1 score, AUC, and MCC. So that we notice in this term where we see that in every aspects that how we notice the performance. And now here also we try to check out whether our model is working, whether our model is able to capture the things or not. So here you can see its visualization part, like our basically the model which is responsible for extracting spatial information. So here you can see this is the original image. Now the how model is able. So here we are trying with the, like a heat map. So here we can see this person is there. So that person is now going to be detected because rest of the context that is written text which is based upon this. So one of the model which basically that we check and visualize it whether our visual model is working or not. So that's why this multi-kernel or visual attention models that there. So here also in this few of the other images, which also we can see that exactly over the person that is just trying and trying to highlight that. So spatial region, importance that we can see that how it works. So here we also perform are the performance which we notice that also we compare with the other states of ours. So in general, we can notice all those parameters with the performances that we have noticed that the R proposed model that even gives better performance as compared to others. So here this one we also perform that whether this kind of to a stream network but it's required or not, and also the attention which we utilizes, so we use to perform the ablation study. So that's why, because sometimes we used to think that if we do the multimodal even a multi-stream network, then that definitely perform better we think of. But we have to check it whether one modality is okay or not. Even some modules that we are introducing, so we have to check whether without that module is possible or not, how the performance is. So that analysis that is going to be basically checked in the ablation trials. So here we see like the text only branch, if we apply, then we can see the performance. And once we use that one, then we can see how this attention without attention and that goes, and the proposed one which we apply. So definitely the proposed one is a multimodal two stream network. So that is a overall we can notice the performance is superior in all data sets that we are noticing. So here also generalization results means across data set once we trying to test, means this is train on this data set multi of and this, and we try to test on this one. then we are also noticing our performances looks good, and which is a very important, specifically for the deployment. Your model should be generalized, so uh, that we have a different data set. So this is our one of the good aspects that we can use to make model more generalized, even offline work, which we can see even in laboratory, that we can say that this kind of things even can, because before going to deploy the model, so that we have such kind of liberty, and that we do this kind of analysis. So here also we can notice the generalization results, how this same data set evaluation, and then across other data set evaluation, how this performance or accuracy that we notice. So we get somehow a good kind of means generalization result to over the model which we built up. So multimodal hate speech, that is a very means now in these days very challenging aspects, and which we need to address, we need to identify. So here one more model of multimodal hate speech detection, which also we can see and we can notice that how it performs. So which is a basically in this one, the top model we can see, top means layer, that top stream that we can see, in the bottom stream, this stream is more responsible for text, this is a more responsible for the images, and which we try to detect. But here the images that we are going to have, that images we are trying to perform like patch based embedding, then we try to incorporate a vision attention mechanism encoder, means like each and every patches we try to get the important information. And like similarly on the bottom side, which we have a caption attention mechanism encoder that we apply. So then encode the basically the caption sequence by token and generating position embedding. So and there is a combining attention based on deep learnings, and then we have so patch embedding. What exactly in this one, the images which we have that we are trying to means with the patches of a 16 cross 16 convolution having a style in means 16, and then we are trying to generate the embedding multiply with the embedded vector. And basically this what exactly embedded to create a patch embedding. And then like a vision attention mechanism encoder, which is a more of responsible, that is for the to understand input abstract and representation, that even divides the input patches into several heads. So overall it is going to be means combined with the multi MLP layer, which contained one hidden and output layer, which is going to be combined. And then combination attention based deep learning mechanism, that is used. So it utilizes softmax classifier to generate the input samples as either hateful or not. So that we used to have. So even this is a hyperparameter specification for this particular model. We have used these three data sets which we demonstrated earlier. For that data sets, the optimizer, learning rate, bias size epoch, that we have taken this. And then the training set, that and the validation set and testing set, that also be split in this form for this particular data set. And then we notice our performance, means real performance of the model on these three data sets that we have demonstrated. Over these data sets, overall we can see our model performance in general notice that looks even better than the other state of arts. So here also we try to understand that whether the multiple modalities that are good or not for the fusion. So we find in case of unimodal, once we text only and visual only we have, then also we notice and we find the accuracy. And similarly for the multimodal, once we have, then with attention and without attention, means without visual semantic attention, without self attention, that is a, so even without self vision attention mechanism. So once we have, so all those subparts that we try to how much it makes importance. So overall we find that the proposed one is always giving a good and better performance significantly with the earlier procedures single one. So here also we see the qualitative analysis, means we try to check it how it's qualitatively performing better. So here also we can see the over the heat map, over the like like individual person, which we try to even see our objects, which we are trying to see that we are even trying to focus more over there. So whether those regions are our model is able to focus or not. So here we can clearly see that our model is focusing on the target what exactly we plan. So we can validate with that one. And so what exactly we now summarize the future direction for the hate species. That is we try to even there are many challenges and trends that we have noticed, like here means neuro symbolic AI or even LLM enhanced contents means predicted learning. And there are some key problems that we are noticing also, like lack of logical reasoning and explainability that we use notices, and also in respect of the LLMs missing historical and cultural means context. So overall, what exactly we see, like the future in there has to very clear cut policy guided means guidelines for the AI based this, and also there is always need to have a human AI collaboration means for the moderation. So means in the future it may be even a it can be even implemented into all those social networks, as well as the now sometime we used to have like over the WhatsApp etc we are sharing. But if WhatsApp they people wants, then if there is any hide content once you are getting, so it the once you are going to forward, it can be blocked, it may be not be. So in future we will definitely see such kind of things that can be there. So with this, I can even again thank you. And if anyone has any queries, so I would even love to listen. If you have any query, please.
So any question from the participants?
Yes, if anyone has any queries, so please.
So they are commenting that the very informative session, and it's
Sir,
very good
I have a
session that you
question,
have
sir.
given.
Sir, I
Yeah,
have a
Sunny
question,
sir.
sir.
Sure.
Sir, the implementation part, how you have implemented all these things, that the results that you have shown.
Yeah.
Sir, implementation.
Yeah, implementation. We did this implementation that over the basically what we use TensorFlow over there, and some of the implementation that we use over the Pythons that we use for this implementation. And here are basics. If you are going to one of the stream for the NLP based model, and then there is a for the basically a CNN based model that we use to implement. Because in the multimodalities, what we exactly notice that there is a text data and there is a images. So we try to model in such a way that the one module that would be extracting more of a basically a textual information, and then there is a more of a spatial information. Then we try to fuse it, and the implementation more of only we can say about the what with the model that we used to have in the sequential data once we have. So for that, how we can extract the information. So that is the base concept. If I like tell the simple way, like if you have very simple, because the thought initial thought we can think of like you have images and text, then one model that can be text data like RNN or LSTM that can process, because that understand the sequential text data have a sequential understanding. And now the top layer that we can have a convolutional neural network. So we try to accordingly, but in that we try to extract the more important cues that has to detected by the model, so that our inference and understanding towards a hate speech that has to be more. So in that way we try to model the which we even presented in. Yes, Aswin.
Yes, sir. Yes, sir. I'm just trying to relate what I have done and what you have explained. I'm just trying to relate those things. The problems what I faced during my implementation,
Okay.
I was just trying to relate with what you are explaining the things.
Okay, but the things that has to be, because it's multimodal data. So in the like the models now, what exactly we always try to get something new. So that's why in the research part generally we try to add some new model, specifically like I can say about the attention mechanism that we incorporated. Because in the text data are also now, initially it started from the text data, but now people are also trying to make the attention over the visual data too. Because once you have images, over the images, entire image is not useful. Some of the context which you are trying to detect, like if you are making any comment or with using a image of that, so image has other parts too, but that has to relate with the your caption too. So both that we are trying to extract in such a way so that our inference that has to be better, like for the classification of heat and non-heat.
So someone has asked about, sir, symbolic neural network working with how in CNN.
What question? Yeah, please repeat.
So the question is that symbolic neural network working with how in CNN. How the CNN work in symbolic neural network? Someone has asked about it.
Neural network in CNN.
Yeah, sir, he is asking about symbolic neural network.
Okay, so symbolic neural network, it is a basically symbolic neural network. If I say, then basically again, if I say like a symbolic neural network is specifically in terms of like a symbols, etc. If we are going to, otherwise neural network is simply we have an input layer and we have a hidden layer and then we have an output layer. But the what kind of basically information we are passing in that respect, we can say it one. Otherwise, I don't understand more of a like a in terms of a symbolic how we can say more of it. But neural network, if we are saying to neural network is not able to basically if in terms of a text data we can say, so neural network will not tell what was the past output that you have, because it is not going to relate with your past. But in case of I say neural network, we are changing in terms of RNN. So that will also going to relate what is the past stamp. Past stamp that also can be related. So in case of specifically text data, it is very important that the sequential like any next word that is going to predict it based upon the past one. So once I'm going writing like I'm going to somewhere. Once you are writing I'm going, then next word that will be predicted based upon the past one. So in neural network it is not possible, but again we are trying to like modify recurrent neural network. In that case, it is possible. But in CNN it is not possible. CNN only that extracts basically the spatial information, which is spatially spread over the entire images.
Yes, sir. Any other questions anyone have? So I guess no question now. So thank you very much, sir, for your highly informative session on hate speech detection in text, images, and videos. Your session gave us a clear sorry. Your session gave us a clear understanding of challenges and techniques involved in harmful content across multiple modalities. I particularly appreciate the way you have explained the integration of AI method for text, image, and videos, making a complex topic easy to follow the practically relevance. The example and use case studies you have shared were very engaging and highlighting both the technical and ethical consideration in hate speech detection. Your insights will undoubtedly help us in applying AI responsibly and affecting in real research and academic project. Thank you so much, sir, for your wonderful session.
Thank you, Dr. Setu. Thank you very much. Thank you very much, Dr. Setu. Thank you
Thank you,
very
sir.
much.
Thank you so much. So, 6 minutes of break. So we will meet at 7:30. So stay tuned. So we will meet at 7:30. The next speaker will join us. So stay tuned here. The next, the next session was led by Mr. Nagendra Sharma, Senior Director, DEMCO, North America. So he will be here with us. The topic he will discuss, that is mechanistic interpretability of deep neural networks, the mathematical foundation and real world AI system. So he will talk more about the mathematics and other stuff about the mechanistic interpretability in deep neural network. So stay tuned. We will meet at 7:30. Thank you so much.
Hi team, good evening. Am I audible?
Yeah, Nagin sir has joined us. Yeah, sir, you are audible. Just hold
Perfect.
on, sir. I'm just telling backend team to switch on the cameras because he has delivered it. The backend team kindly enable the cameras of sir as well as mine. Vikas, can you hear us? कुछ जरा वीडियो ऑन कर देना नागेन सर का और मेरा वो लिख रहा है yeah. Yeah, Nagin sir. Hi, how are you?
I'm awesome. Are you able to see my video?
Yeah. We are able to see your video. Sir, we
Okay.
will wait for 3 minutes and then we
Yeah,
will start the
sure.
session.
Please take your time. Thank you.
Yeah, sure, sir. So thank you so much, sir. Yeah. So now we will move to the session 11. So the session 11 on the topic mechanistic interpretability of deep neural network, mathematical foundation and real world AI system. It is my great honor to introduce Mr. Nagendra Sharma, a distinguished technology leader, enterprise architect and AI strategist, currently serving as senior director as Demco Solution North America. Mr. Sharma has over 25 years of experience in the global IT industry, specialization in AI, generative AI, agentic AI, machine learning, enterprise architecture, and digital transformation. In his current role, he leads strategic initiative to deliver AI-powered, cloud-native, and scalable enterprise solution, working closely with global client to align technology with business outcome. He holds an Advanced Chief Technical Officer (CTO) program certification from MIT Professional Education 2024 2025 and has held senior leadership position at DeepMind's Technology, Capgemini, and other multinational companies, and also expertise on software engineering, agile, DevOps, and large-scale digital transformation. Mr. Sharma is also recognized through leader and technological by sharing insights on cloud-native architecture, API ecosystem, enterprise modularization, and AI adoption. So we are truly honored to have him with us today in FDP. Please join me in welcoming Mr. Nagendra Sharma, sir. Over to you, sir. Thank you. Thank you so much.
Thank you, Shwet, for very nice introduction. Much appreciated. And it is a pleasure to connect with all of you. And thank you. I will start sharing my screen and we'll have this interactive session. Actually, I have my CEO review at another 1 hour exactly. So, but still,
Okay.
but definitely, my plan is that in March 1st and 2nd week, I will be in your university over there. I think in 2nd week, I will be there. So I will be meeting you in
Yes,
person.
sir.
So glad to connect
Exactly,
with
sir.
you and let me share my screen.
Yes,
And
sir.
please confirm if you are able to see my screen.
Yes, sir. Yes, sir.
Okay, so
We are able to see. Yes.
okay, so let me make a big screen so that I minimize most of the thing. So hope you are able to hear as well as you are able to see my screen, correct?
Yes, sir. Yes, sir.
Okay,
Yes.
perfect.
Yes.
So let me go there. So already, I think, thank you, Shwet, for nice introduction. So I will not take much time. We'll discuss more on the, let's say, real world, how we will leverage the mathematical foundations, as well as how the mechanistic interpretability is now a new norm for the world because world is moving. So definitely, I think you have told. So definitely, so yeah, this is sweet kind of thing about me already. Shwet has told, but yes, I am vice president and CTO for Demco Services, and coming to the, I just want to give for Demco because this will give for your perspective. We are doing a lot of investment in the AI ML research and development. So for example, you are working with so many students and all those things, make sure we are happy to help them and help to shape their career. So Demco is based in Gurgaon, Faridabad, as well as in Noida, as well as across the globe. But in our local, in if I'm considering for our UP or NCR, then we are having a great presence over there. And mostly we are making, and my goal is here that how we can have the whatever investment we are making in research and development in the field of AI ML. So our most of the customers are in healthcare, insurance, and even I'm leading couple of product innovation, leveraging the agentic AI platforms, leveraging the best AI model, or let's say industry data cloud. Maybe you can research. This is my home assignment to all of you. Please research on industry data cloud. So a lot of norms are going like how we can have the data set and your model ready, made a training data set. So we are doing so much research on, again, I'm saying healthcare. We are having a lot of great healthcare solutions. And in United States, most of the healthcare provider or solutions we are having our solutions are helping them like underwriter or some kind of, let's say, in the insurance, as well as providing the recommendation. So that's about the company where I am working. Previously, I have worked with the lot of large organization. I started my career from DRDO as a scientist in Delhi, and then after that, I joined TCS, Infosys, Wipro. With Wipro, I came to US around 13, 14 years back, and from last, let's say, 13 years, I have traveled across the lot of organization, lot of switches I have done in the search of that where the I can get the more on this innovation and collaboration kind of thing, because now that's my passion. So this is about the company and about me. I have at the last I will share this with Shwet also, so that lot of contacts are there. Suppose your training placement department want to work with our HR department. We are having a lot of kind of interns, lot of kind of AI ML engineers requirement that's keep on going for my teams to build up in India as well as in United States. So happy to help you, like, because it will be good where to get the known faces in our work and we can make a innovative products. Okay. Okay, thank you. So next I will be moving this. Okay. Again, I'm checking. Hope you are able to see my screen now. Okay. So now the agenda is very simple. We will be going through the mechanistic interpretability, because my last, I think, session, some of you have joined or not, was on the explainable AI. So mostly based on the trend is going, and that's I'm telling the most of the agentic AI or our real life products are not going into the production because we are not able to tell what is inside the black box. We are not able to open the black box. We are not able to explain, or we are not able to, and that's why we are failing to get a buy-in from our external stakeholders, because they are non-technical. Everybody is not aware of that what model works, and that's why they want very detailed kind of thing. And that's why mechanistic interpretability matters a lot, because and this is providing our researchers to, or this is just like that we are having some legacy. Somebody has written a code around, let's say, 40 years back in COBOL or Fortran 77 or some older languages, and now you require a reverse engineering, because then only you can decode, or then only you can write a. So similarly for mechanistic interpretability perspective, if I will see that we are having a lot of kind of thing, we are having a lot of opaque kind of situation, inscrutable kind of black box situations we are having, and that's how mechanistic interpretability help us to open that black box, provide us the inner workings, that how the granular level details are happening. So that's why we can think that mechanistic interpretability or explainable AI, and that's why maybe in the market, let's say if you have done, let's say there is a lot of OpenAI microscope, or for example, Claude or Anthropic, their business is very much growing in the market. If like we are building a product, so more product selling is happening for the people or for the companies who are making investment in more on explainable AI, ethical AI, or I will say in mechanistic interpretability. So that's the background I just want to go give, because lot of high stake domains, like I have told, healthcare and finance, especially healthcare and finance, where there is a flawless delivery or without biased kind of recommendation, or let's say some kind of notification is required, not like that we are getting. So for high stake domains, or there is a lot of regulatory requirements, because in each organization, and based on my experience, because I am playing a lot of role on the technology, let's say CTO side, but it's still sometime whatever capable I am here, but if my CISO, like chief security officer, if he or she tell that, okay, this is not safe to implement, lot of my, let's say, investment, for example, as I said, 80%, and you can Google it, only 20 now 17 to 20% models or agentic AI platform, or let's say AI ML solutions are going into production. After otherwise, let's say your 80 to 85% are just dropped after, let's say you have done system integration testing, you have done a lot of kind of thing, because so whatever research we have made, that is not going to make. So that's why whatever the, let's say, we can't just tell like, okay, assume it. And that's why only we see that mechanistic interpretability can move us from our traditional interpretability methods to the more on the decision making processes, that we give a very comprehensive kind of report, so that the leadership, because lot of the decision, let me tell you, in the technology, 20% decisions are made by the technical team, but 90%, like the Pareto analysis kind of rule, 20% is we can control, but 80% of the decision making of successful production rollout of any AI system is dependent on so many people. Cost is not a factor, but cost sometimes comes, but mostly it comes whenever there is a regulatory requirement. So that's why I feel highly that for high stake domains or for regulatory requirement perspective, this is a must. In addition to that, let's say, okay, I agree that, okay, it will give a lot of reverse engineering. It can provide us a more deep learning models, more kind of more inner working. But for the business perspective, because I'm just want to tell you about the real world perspective, for regulatory requirement perspective, it is very clear. Like I'm just saying, whatever model, let's say I'm building here for a one healthcare provider, that will not work in United Kingdom, whatever I'm making in United States, because there we have to apply the GDPR requirement, there are other SOX compliance, so many compliance will come. So if whatever AI platform I am making and it is not interpretable, then definitely it will not help. So that's why I just want to tell that to whenever we are building our future aspirant, or let's say future leaders in this space from the college like MMTU, that definitely we have to put in their brain that, okay, building models is not very difficult. Let's say you can have the foundation model, you can have a lot of tooling or all cursor.ai, you can use so many things. But if you are not thinking about that, how the domains will suffer out of it if we are not able to reduce the bias. So that is, I just want to put. And again, we have talked on there. So first was that the core message from the previous one, that, okay, why it is matters. Now it important is that okay, from different people are having different definitions. So my definitions is always coming from the it may be difference from you. It is coming from the practical experience perspective. So for us, the mechanistic interpretability is that first important part is that how we are computing model internally, so that, let's say I am the data scientist and I am having a product owner, I can tell that, okay, how the intention, how the all kind of, let's say, what is my intention of my model itself, or as well as what kind of, let's say, I can get the inner working out of it. Because in future, for example, any fine tuning or any kind of, let's say, understanding is required, so that we can see, or we never know, let's say after 2 years or 3 years, we have to again do some kind of, let's say, reverse engineering of neural network, so that because some new technology has come and we have to infuse or we have to leverage them for future research, then we can do the reverse engineering also. Because maybe some other leaders has told or not, but our let's say IT industry, or especially based on my 25 years of experience, we are very good in coding, we are very good in that, but even for the traditional coding perspective, documentation is very less. Because a lot of the organizations are going for modernization because they don't have the documentation of whatever they have done 20 years back. That time they were thinking that, okay, one time it is done, it is enough. So that's why, let's say, future, if we are thinking, suppose not many, let's say, multi-model or some other approach is coming, or some other, let's say, we are leveraging more on the quantum mechanics or quantum computing we will be using that time. So maybe that time reverse engineering is required. So definitely mechanistic interpretability is helping us for reverse, if you ask me from the industry perspective, for me, reverse engineering is much, much important. In addition to that, definitely it is helping the neuroscience and system engineering people in this background. So definitely, so that's why this is important. Now, little bit, I want to, as I said that previously, I think last month, I have talked about the explainability, but just I want to just change because from the system perspective, because still people think that explainability is the same, AI explainability is the same as the interpretability. So it is explainability just like that. If I will term is that, let's say I'm a product owner. So I will more focus on interpretability, but I am a business leader, I am a salesperson, I am more focusing on a explainability perspective. So that kind of, I will see that interpretability is more for opening the black box of AI, revealing the mechanism behind how the each decision was made, how the each computation has been made, as well as what kind of activations or circuits or baits or layers, all those kind of things. So as I said, this is interpretability giving more on the scientific analysis perspective, wherever explainability is giving you more about the, like, let's say we are leveraging a lot of Shapley and Lime and all those kind of things, but they are just providing the explainable, or that just think like a business. So you can't, let's say, isolate both of them. Interpretability is required by explainability, or explainability person, when we are, let's say if sales person may require explainability, but when we are going for a chief security officer, that he and she may ask more on the interpretability also for that perspective. So that's why explainability is more on, let's say, overall summarization you can see or give the justification, but interpretability will give the total understanding how the each kind of, let's say, layers and activations, each models, each neurons, how the each neurons is providing the actions for next one, and how a overall circuit is working. So interpretability is, you can think about the deeper dive kind of thing, wherever explainability is gives you the some kind of, let's say, some more on the providing a summarization to provide the trust, to validate or provide those kind of thing. But without interpretability, you can't do the explainability. That's very clear. Okay. Otherwise, explainability just like that on, let's say, 30,000 feet, you have given the overview. But when somebody asks like more deeper questions, that time interpretability will come, that how actually your each model is behaving, is so many layers is required. For example, you want to optimize, let's say FinOps is another concept. Do we really require those many layers? Do we require those many parameter? What level of data required? So that only interpretability can help, not explainability that time. And after that, let's say, so we want to go about the foundations. Look like that how we will drive that part. For example, now we reach that point very clearly that, okay, explainability is also important, interpretability is also very important, but at the same time, but how we will achieve it? Because so this is the very, now the important point here coming, like, okay, how you will achieve it, what kind of mathematical functions or how we will use. So everybody, because here all the AI researchers, and you know that earlier when I was doing linear algebra in my university days, I have forgot to tell you, but I have done my engineering and masters from Aligarh Muslim University, AMU Aligarh. So that time when I was understanding linear algebra and all those things in that time, so definitely I was seeing what is the use, but really I think linear algebra and calculus are the key, where a lot of mathematical foundations or a lot of things we can do. So definitely if we are seeing from that the lens of the mathematics, that vectors and matrices and tensors, how they can help us for representing our right inputs, right parameters, and activations in neural network also, so that we can quantify, let's say, how much is required. So behind any kind of explainability, or let's say whatever interpretability you have, some mathematical function definitely you should have. And so that perspective, if we are coming about the, let's say, vector embeddings, because if you say semantic search and lot of things now, a lot of vector embedding, and maybe you heard the vector databases now growing very fast for making semantic search, because now a lot of search you have to do. So that's why. So embedding also, and that is also helping for how you can make sure that you can encode a discrete entities into a geometric object, so that you can provide a dimension space, and so that like similarity search or clustering, all those kind of reasoning you can do out of it. So lot of kind of, let's say, if you see the vector databases behind the core architecture of vector databases, that now a lot of AI ML like Pinecone, and I think you can research like Radish and so many other vendors are emerging as a very good, I will say the top 10 vendors in the space of vector database. Their core important is that how they are doing the embedding, and that embedding again coming from our linear algebra. And similarly, those can, because if we understand that how the embeddings are there, then we can fine tune our model to provide the right interpretability level also. So that's how I can see, and the same for eigenvalues and eigenvectors also, as you know. So like, because vector search, how you are doing, and so those kind of, again coming from the foundation is for us is a linear algebra itself. And last but not least, because that kind of, again I have to put that subspace analysis also, how we are making sure that the uh, representation, how is we are happening, how we are doing the optimization model also, as well as how we are doing the network compression and interpretability out of it. So all those things, definitely what I can say that our linear algebra is the foundation of AI, which is providing the mathematical machinery to either we have to represent or transform, or making the reasoning out of high dimensional data. So definitely that is a key things, and I think that we missed. And still I feel so many times that though I was the at the time, definitely I was the highest scorer in university also, I'm gold medalist from there, but I still feel I should have done more work on linear algebra or calculus that time. I have done more research over there, than today my life will be more easier. So that's a very focused area for the linear algebra perspective. uh, Here is a short kind of thing. Again, I have, let's say, each part, whatever I have mentioned, 1, 2, 3, 4. So how these, what is the role? Because my topic of today's discussion is more on the mathematical side, to give a, let's say, to show some light. Maybe you all knows better than me, but just refocusing from my lens here, that yes, those component, how the vector is very important for us for interpretability, how the metrics also helping us, and how the tensors are helping us, because as you know or not, a lot of, let's say, whatever tensor flow or all those things is coming from that tensor concept also. So definitely, if we are seeing that our vectors, matrices and tensors are the building blocks for neural networks, and definitely when they are the building blocks, then if we will reveal them, if we know that how we are using them, then definitely we can see the how the feature sensitivity we are having, how the activation patching is happening, so that we can test our causal effects, right? And similarly, let's say if we are going to matrix side, that can analyze our transformation between layers. Let's say for example, layer 1 is doing only some kind of semantic or word matching, level 2 we are doing some grammar kind of thing, and layer, let's say 10, we are leveraging some kind of more validations kind of thing. So between the layers itself, how the transformation is happening in neural network, then those kind of thing comes from the matrix that will identify some kind of dominant directions via eigenvectors. And similarly, when we come to tensors, so tensor definitely provide us for multi-dimensional array representation with, for example, I am having a batch input, a lot of IoT kind of data where a lot of, let's say, heavy data is coming, and how the sequence is happening, how the multi-head attention outputs I want from that, so that tensor can help like with the 3D scoring activation, as well as a lot of sequencing we can do. So that's how we can see that a lot of, let's say, precise analysis, manipulation, and understanding of how models represent and compute complex concepts. So there definitely vector metrics and tensors will be helping. Coming to the embeddings, because this is my favorite thing, and I think because you are all the research and development and scientists here in this call, and you see that because that comes because the person who coined the word like vector database, maybe whatever time, now you can see a complete industry is running behind the vector database after Gen AI emergence is happening. So if we see that concept coming from the embeddings also, how the vector embeddings works, how that works. So if you can see that semantic search or all those kind of thing. So definitely what we can see that embeddings transform a lot of discrete entities into geometric structure so that you can make sure that a mechanistic interpretability model will be there where we can have the clustering like all you know, so I should not do all the similarity search, nearest neighbor algorithm or clustering algorithm and all those things. You can get the semantic reasoning out within the neural network also. So that's how the not only embedding is helping in plain data, but here also embedding also helping in the same form where you can do the starting from the complete representation itself. Oh, just a minute. Yes. So third point is here that more on the how we are thinking of from the mathematical perspective, eigenvalues and eigenvectors. I will not go. I will definitely share this one for you, but I want to just again share here that how these mathematical aspects are helping us for making sure that any kind of variance or any kind of, let's say, some kind of when we are making benchmarking of that neural representation, we can make sure that how much deviation is there, and this will give us a complete kind of thing whether we have to do some kind of dimensional reduction or we have to do more analysis of this model dynamics so that we can provide the ethical result or more interpretable result in this direction of mathematics itself. Coming last point in this, the same point in the same series is more that how subspace analysis exposing the underlying structure of neural representation, providing insights that guide optimization, compression, and mechanistic interpretability of models. So those are the key aspect where how we can do the optimization itself, like how we can make sure that some kind of redundant or overlapping representations are there, and then again according to that how we can do our weight adjustment as well as providing compression, and at the same time we are not losing any task relevant information so that this is giving us optimization. So for example, we are removing neurons in low variance kind of subspaces to reduce model size while maintaining accuracy. So we shouldn't require so many neurons, or we should not require so many layers over there, so that let's say it is not confusing. If so, those kind of optimization will definitely help us in that kind of thing. And definitely, so this subspace analysis definitely from the mathematical functions will help us to have our network compression, interpretability. It will give us the inference for optimization, and at the same time it will be providing or analyzing us that transformer layers so that how the neurons cluster is formed to provide, let's say, subject in case of your complete sentence or verbs and noun, how you can make it out of it. And now we are discussing about that part also. So on the mathematics perspective, so how the optimization and loss kind of a concrete example, I just want to tell that how the optimization dynamics and loss landscape geometry fundamentally can help us. And definitely gradient descent dynamics, everybody has gone through with it because that is a very good concept. So how you can make sure that how much training is required, how we have to shape for internal feature representation perspective. If we come to the loss landscape perspective, then how we can make sure that flat minima improve for our, let's say, very robust and to make us to provide a generalization. And so those kind of, let's say, optimization, as much as optimization and as much as we will try to make some kind of generalization, that can give us like our interpret result out of it. So definitely, if we can think about that, our optimization behavior and model scale shape not only performance, but also the structure and interpretability of LUD representations also. Another in the same concept, because we are going, first we discussed about the linear algebra, then that one, and in the same concept also, that another foundation definitely help is information theory. Maybe I think everyone has gone through with that. So how the information theory, if let's say if we go for uh, their simple kind of definition, it is providing us a mathematical framework where we can quantify like the how much information is required, or let's say information is measured and encoded and transmitted and preserved in signals and representations. So a lot of kind of, let's say, so IoT signals and all those things, they are lot of information we are making sure, so that will helping us that uh, how much encoding is required, how much interpretability is required, as well as, so information theory gives us the one more kind of, it reveals the what neural network choose to preserve and what we should discard, so that let's say we should not be at the end of that we should not have the bias, or some kind of edge cases can be stopped or cannot be taken care for that. Another part we are coming about after information theory is that how the causal reasoning we are helping us, how what is the role of causal reasoning in transforming the analysis. So this can help us because causal reasoning is definitely give us the cause and effect and relationship, and that's why we can think about that. Okay, we can interpret what is happening inside it. So lot of, let's say, if we have to discuss about the interventions on activation and baits, so definitely how we are manipulating the internal component to test causal impact on outputs. So definitely the cause effect relationships, and uh, that give us that more on the correlation, as well as helping us to a pathways for how the responsible for specific behavior is coming out of it. So definitely they are helping us to support the mechanistic interpretability, as well as we can debug, so that let's say some fine tuning is required, as well as some kind of some layers we have to add or make. So definitely this is giving the a complete cause and effect kind of graph, where we are zeroing out a neuron, detecting negation if let's say some kind of causes model misinterpret a note for that also. Now that we discussed about the concepts, that okay, how till this point, let's say what are the key kind of like techniques, or before I will not say techniques, but key process or key kind of, let's say, foundation for reaching that point, how we can achieve in mathematical terms perspective, so that if we are very good in mathematics, those kind of, if we are leveraging the information theory, how we can make it. But this is the more thing, that what are the core techniques in mechanistic interpretability. So that is the part that how we are starting. So I want to spend some time here, that uh, how to achieve it. What are the techniques also, because definitely a lot of tools are there, a lot of kind of guidance is there, but uh, how to proceed with that. So these are the, let's say, if let's say top five, I can see the core techniques that will start, that we are leveraging here more on our R&D product development using where our goal is that to provide the mechanistic interpretability. It start with the activation patching, where we can leverage the modify internal activation to test causal impact on outputs. So that is the first technique we are doing. Second, let's say how to discover the circuit itself. So circuit identification is the second, where we are making sure that we are discovering the networks of neurons, heads, and implement reasoning behavior, because so that it is just like we can think about that. We know the IT asset management, so IT discovery kind of thing. So here we can think about the network discovery of neurons, so that we know that each one of them, what are their use cases of each of the neuron. And like third technique is that how we can do the superposition and polysemanticity, so that we can say that, okay, how the neurons are encoding and away for the overlapping concept in a shared space, so that we can come out of the overlapping also, uh, so that we can again optimize that part also. Another technique is that how the neuron ablation and interventions are being incorporated, so that we can remove or perturb some component to reveal functional importance. Let's say one component is not shadowing others, so that we can have the clarity on that thing. So that is another technique that will give a more clarity in this space where we are going. And last but not least, definitely a feature visualization. And that's why those, let's say I told one to OpenAI microscope, like how we can have the visualization more on the feature visualization, can give us the optimize us that, okay, let's say what is the use of what this particular neurons and heads detects out of it. So definitely but I can see that these techniques move interpretability from surface level explainable to casual mechanistic understanding of how neural networks compute, reason, and generalize. So all those point is that because if we understand very well that how we are computing the neural network, what is the reason, and how we can quickly generalize it, if those techniques are helping us, then definitely we can say that those are implementing our mechanistic interpretability perspective. So these are there may be many, but based on, let's say, in real world, we are leveraging them that we can quickly provide and generalize this one. Now, now coming to the, let's say in the previous one, we have discussed that, okay, like how those technology can be implemented, but maybe you are aware, but I just want to take out of it that neurons and feature. So little bit kind of thing, but I definitely have, but uh, based on the overall kind of, if we are going to this flow, that coming to that new, what are the neurons and features? So if we are saying, so building, as you know, in very important, but I want to focus on more on the key takeaways also, that neurons vary in specificity and overlap, reflecting the efficiency and complexity of neural representation. So those, making sure that at when we are, let's say, at neuron level also activation, we are making sure we are revealing how models capture concepts, structure, and semantics. So that will providing more interpretability and mechanistic insights itself. So at the time of we are forming, let's say feature one, feature two, and then your neural network and what is the output is coming, making sure that your neurons in neural network encode both single and multiple features, understanding their activations, uncover interpretable representation that explain how models capture concept, structure, and semantics. So those that will definitely help us for that perspective. Uh, Again, for the feature validation, feature visualization perspective, this is definitely because, as I said, feature visualization provides a let's say dashboard or a window where we can see that what neural network encodes, or what kind of, let's say, complex gaps can be uh, highlighted, or some pattern we can see based on our, let's say, historical perspective. Let's say this feature was working in last that way, and now it is working in this format. So those kind of things. So definitely the feature visualization, when we are going in this interpretability, is the key things, because easily you can reveal the core idea that what neurons or component respond by optimizing these inputs, and as well as it provides a lot of representation related to that how the internal behavior of the neuron is working. And definitely it can provide us the overall, I will say, a vision, as well as in the nowadays you can represent in both format also. That's more on visualization we can provide us for in that terms, I can say. And here is like just like it is like how the feature visualization reveals what neurons respond to, showing the patterns and concept, whether it is a visual or it is a linguistic. So those kind of then that can drive the lot of activations. So we can understand from each one of them ki how what neuron is doing the next step of the activation, and based on that, so definitely the feature visualization will help us and provide the lot of, let's say, whether sentiment or syntax or grammar or how the roles are coming. So that definitely feature visualization will help us in that space. Definitely we have coming to that one, but let's say it is just kind of, I'm just thinking from the that terminology perspective, that how the circuits in neural network works and how they are helping us, what is their thing. But definitely if neural circuits, how we are forming them. 1 minute. And last but not least, because we are keep on going, I'm just rushing it, but yeah, those uh, proving and representation analysis will definitely help us for how the interpretability can work, whether, so there is a lot of concept like whether how we are doing the linear proofs, linguistic probing, bias and fairness probing, limitations of probing. So that can help us. So probing definitely exposes us the knowledge hidden in the neural representation. So definitely these techniques can help us to inspect and evaluate what information neural networks encode in their internal representation by using targeted, let's say, proofs we are doing to uncover any linguistic problem, factual or some kind of bias related knowledge is there, so that we can check that model is not encoding some unwanted social biases or some stereotypes. So bias and fairness proving, definitely these are the, let's say, methods also how we are doing the QA for the neural network itself. Uh, Coming to the interpretability perspective, what are the tool frameworks that we are even leveraging at DEMCO? So as I said, that OpenAI microscope we are using for the visualization, how the neuron activation is doing, and definitely it will help us. So this is a OpenAI product, and it is giving a lot of visual features, as well as it is providing us the recommendation also. Uh, we are leveraging circuits Viz also, that is for interactive circuit analysis for mechanistic interpretability visualization. And this will help us in analyzing the functional circuits and attention heads in transformer level. Uh, Transformer lens also we are using, that is for transformer model and introspection. There is a PyTorch Captum. Captum is used for model interpretability for PyTorch, and last but not least, like Shep and Lime, everyone is using, that is for more on explainability side. So these are the tools and frameworks are being used for making it us. And coming to the let's say uh, I have couple of use cases also, like from telling that how the mechanistic interpretability framework. So this is for the more on the interpretability industry, that is the AI ML industry, how we are transforming complex AI model into transparent, reliable, ethical aligned system. But if we are going for healthcare perspective, because real world use cases, so there lot of, let's say, uh, how why interpretability is required for healthcare AI. There it is very important that how we are understanding the model prediction that will explain us diagnostic model prediction for clinical transparency. At the same time, any kind of image based interpretation is required by the neural network, so that medical imaging, so a lot of X-ray, MRI, CT. So there we are also implementing a lot of like this framework uh, for us. But what I can see also that here in even healthcare perspective, the interpretability turns our healthcare, lot of AI systems, lot of making our customer more trustworthy, whether it is a provider, doctors, or insurance providers. That gives us a lot of kind of, I can say, clinicians' trust and adoption is improving. Because let's say whatever system you make, if trust is not generated, then adoption of the system is not going to happen. So in I can say that in healthcare, this is very, very essential for us for translating those AI models, black box information, and converting into the clinicable actionable decision out of it. So that is helping, as I'm again repeating here, that this is definitely helping strengthening our clinical trust and accelerating the adoption of whatever healthcare AI product we have made. Finance is another part also, because in finance where a lot of fraud detections are happening, and so how we can penetrate that any kind of credit risk decision can made, where we can, because let's say credit history mapping, how we are checking their all, let's say, past records data, there is other parameters also required. So that can come from when we are building the a explainable credit risk decisions, where we are not only just going to run a model on some data, but make sure we are making a decision based on some regulatory compliance, some model governance also. And the same for fraud detection and transparency also. So what we can say that, like, definitely for regulatory compliance perspective, definitely we want the insights out of it, so that we can provide auditability and traceability for the model itself. And definitely it will help us in reducing the bias for automated decisions, whatever we are making. So definitely I can see that interpretability is helping in finance, like BFSI, banking, finance, insurance sector, for more on the making more compliant solution, auditable, and providing a fair financial AI, because we don't want that consumer should lose or any banking or bank organization lose. Both should get the fair financial kind of explanation or credit risk scoring out of it. Another is then like how the, even in the, for example, now we are IT industry or AI ML company, for them how it is helping also, whether it is if we are, for example, if we are building the AI ML product, so what is in it for us? So for us also definitely how we can, because a lot of hallucination, how we can overcome the hallucination kind of problem, that is also helped by interpretability, because we can analyze the internal model reasoning, and accordingly we can optimize or fine tune or whatever, can benchmark our model accordingly. And definitely that, because safety alignment and controllability perspective also, because that is helping us the strengthening of safety and making some controllability of model behavior itself. And last but not least, because the debugging prompts and model behavior, that is come from the interpretability, because now we can enable some systematic debugging, or some kind of, let's say, some prompt is getting failed or some unexpected output is coming. So with the interpretability, what we can do, we are enabling the systematic debugging, and we are making sure that we are providing safe and controllable and reliable model to build a overall entire system. So definitely what we can see that key mechanistic definitely provide the insight for the foundation itself, so that, let's say, if for applied data science itself, if we are applying that, then definitely it will take us a long way. And I think now the challenges in this space is, as we know that, because when we are growing, definitely scalability is a problem, because and for that, how we have to scalable it at a faster, how we can have the, let's say, reduce the ambiguity, and because to set the benchmarking and performance. So those are the, I see the key challenges, because we can't scale as much as we want. So definitely how we are having, and again, because so those are the key challenges in the space of, let's say we are going for mechanistic interpretability. And then if we are thinking this space in future, so future direction is, we can think that future AI will be more powerful, will be required more safe, trustworthy. And if let's say you require powerful, safe, trustworthy, and I want to add one more thing, that production deployment also, because there is of no use of any system even if they are not providing ROI or value to the system in business terms. So if you are not solving any business problem or human problem, and that's why interpretability comes here, because automation is not everything. Automation, definitely automation automate, but is automation is safe? So similarly for this, and that's why the mechanistic interpretability definitely providing the how the automation can be more, I will say, implemented across the board. Not only, let's say, if it started in retail, it should start in BFSI, it should common, it can be happening. And that's why it can help us that whenever we are going forward, it should not be asked, but it should be enabled. So whatever automation we make, the documentation, how the discovery of circuits or their explanation should come automatically. That is the future direction is there, that not like that you are creating another agentic AI platform for interpreting the system A. So you are system A doing some work, but it is not safe or trustworthy. You are creating system B on AI ML that do the interpretability. So unnecessarily that is burden. So how we can make that automated interpretability should be there. That should be the trend. And not only interpretability we are doing, but how we can do the interpretability of, let's say, now currently we are having one agentic AI platform. I am merging two platforms together. How I can do the multi-model, multi-platform kind of thing. So, or let's say, how we can do the multi-model also. So that is another part. And as I said in the one, that integration of two models. So definitely that will help. So future of AI depends not on just building, let's say, smart models, but on building models that we can deeply understand, trust, govern, and last but not least, we can deploy in the production, not only just for fun, because I am seeing that people are treating every company on the earth want to become AI first company. Any even developer want to become the AI scientist, but it is not for fun. It is for reality. Reality will come when, let's say, it should be reverse. Like that now we are having that 20% only in non-production and 80% in production. That day we will see that really we reached on the milestone. But currently I am seeing more AI ML is just for a image of the organization to just press release. We are the AI first company. We are a data first company. Every organization, if you Google it, is written, we are AI first company. And when you ask the definition, what is data, then they can't answer. They don't even have the data warehouse to explain. So what I'm saying, the reality is that building model is not important. How we understand, trust, and how we govern, that will make it. So now this is my last slide here, that what are the key takeaways on the mechanistic interpretability. So definitely we have to more focus. We have to make a mindset that building model is not, it is important. I see it is required, but you can't, it will not go a long way until unless we are opening the black box, unless we are understand how the neural network compute internally. It is going beyond the surface level explanation. If we are having the more focus on the math as a foundation, as I like given that okay, your information theory, your causal reasoning, your linear algebra, definitely those core is required. If you are thinking that some, let's say, OpenAI microscope will come and give you the feature analysis, this is wrong, because it is your model. You have to think about like a mathematician. Same safety and responsibility. We have to, whenever we are designing the model, not only for like, okay, this model will do this, we have to start we are infusing the safety and responsibility from the day one itself when we are designing the AI ML or agentic AI platform itself. And definitely when we are caring for all those things, then definitely you are providing a relevant industrial kind of solutions, not like just fun kind of project. So I think this is it from me. I think we are on time, but I can take any question offline, and I will share this with us. But this is the Shwet I can share with you. You can reach out to our team.
Yeah, sure, sir.
We are looking our AI interns, technical lead, software engineers, or some interns we are having from MMTU. So I can definitely refer them for our research program. Okay. Thank you. Nice talking to all of you, and much appreciated to give me opportunity to talk to you. And definitely it is a good team, and see you if any question comes. So Shweta, I will share this to you. And if any question
Yeah,
comes,
sir.
I'm available for any time, not only let's say 15-20 minutes whenever you want in weekend or weekday. I'm happy to help you, give you more concepts from the some kind
Sure.
of unplanned way also. We are happy to do that. Okay.
Yeah, sure. Any question from the audience? If you want, we will take one or two quick questions. If anyone having any questions.
No, thank you so much. And
Any?
anything you require, please, any
Sure,
kind of,
sure.
let's say special Shwet for this, because we are a group. This is a good 102 people, including me. So that's a great thing.
Yes.
So anything you require, any perspective, as I said, very openly, I'm saying I can introduce to our training placement department. They can work. We are definitely doing a lot of
Exactly.
research work, and it is good that my university people are working with me. That's really a great pride for me, right?
Yeah, sir.
Okay.
We are also honored to have you as an expert, that you have lots of, exposure in this technology and other areas. So we are gaining something from you.
No,
So
definitely. And anything, even I'm gaining, this is reverse way, but we are gaining. I'm very, because this gives the motivation, and happy to help you. And thank you so much again, Shwet, for all that coordination and for the entire team. Please pass my thanks to Rakesh sir for providing this opportunity to talk to you in person. Thank you.
yeah, thank you, sir. Thank you, sir. So, thank you very much, Mr. Sharma, sir, for the enlightening session of mechanistic interpretability of deep neural network, mathematical foundation, and real-world AI system. Your session provided a comprehensive view of how deep neural network can be interpreted from both the mathematical and the practical perspective. I particularly appreciate the way you have connected theoretical fundamentals foundations with the real world AI application, making complex concept easy to understand and highly relevant for research and teaching. The insights you have shared on analyzing internal model structure and on understanding the decision making process were extremely valuable. Your session has certainly enhanced our understanding of interpretability, and it's important to build the reliable and transparent AI system. With this, we conclude day 5, session 11 of FDP. We hope you all have all found the session insightful and valuable. We look forward to have a tomorrow. Thank you so much, Nagen sir, for
Thank you,
your
sir. Thank you.
this valuable session.
Thank you. Much appreciated.
Thank you, sir. There are a couple of announcement. I will share the link on the chat box only, that particular group. Due to some glitch, I am unable to share the attendance link here. So I will share on the on group, on the WhatsApp group. And one more announcement, that tomorrow we have two sessions that start from the same time, that is 6 to 7:30, and the 7:30 to 8:30. And after 8:30 we have like validation session, validatory session for tomorrow, and after that there is some quiz. So the quiz is based on whatever you have learned from this FDP. So tomorrow you can say that there are 4 sessions. The 2 expert talk, and one is a validatory session, and the last one is your this quiz round. Fine. So be prepared for it, and I will share the attendance link on the WhatsApp group. Thank you so much for patient listening. Happy learning. Thank you. Good night.